All right, so in the first part, we left off talking about how to put this into the calculator. Hopefully this is showing up vertically. I know when I looked on the screen, it was horizontal. So hopefully someone can figure out how to change that. All right, so next we're gonna look at the graph of e to the x. So e being 2.72 approximately. It's still the same. If x is 0, okay, then e to the 0 is 1. So it's still going to cross at 1, and it goes right on up there, e to the x. Some of you had done the homework early. It's not due until Tuesday, okay? And that's going to be WebAssign number 14. But in there is a half-life problem. So the half-life of a certain element is 25 years, and the initial mass is 10 grams. They want to know how much mass you'll have after 120 years, given the equation that whatever mass that you'll have at the end of 120 years is given by equals 10, your initial mass, times the half-life. And that half-life is to the t over 25, because your half-life is 25 years. Whereas here, t is 120 years. So you plug in 120 for t, and you want to do as much as you can before you put it in the calculator. So 120 divided by 25 is 4.8. Again, order is important on these. You're going to raise 1/2 to the 4.8 first, and then multiply that by 10. And you get approximately 0.359 grams left. All right. Another problem that comes up a lot with exponential functions is compounding. Different ways of compounding money. So you can either do n compoundings per year, whether it's monthly or quarterly, as the example we have here, or you can continuously compound. If you do so many compoundings per year, the equation is your amount equals your principal times 1 plus the rate over n to the nt, whereas n is going to be quarterly, 4, monthly, 12, etc. Continuous compounding, that's PERT, which you might remember. The amount equals your principal, or what you started with, and then e to the rate times t. So if we start off with $15,000 at a rate of 8%, or 0.08, something we don't see these days, and your time, you want to see what you make over 6 years. It's interesting to see this out to see which is better. So if you do it quarterly, you're going to start with 15,000 quarterly and monthly. We're going to use this equation up here. So you're going to start off with 15,000 times 1 plus your rate, 0.08, over quarterly, 4, to the 4 times how many years? 6. So again, do that in your head, 24. And then you're going to plug into your calculator I would do it 0.08 divided by 4 plus 1, and raise all that to the 24, and then multiply that by 15,000. And you got approximately $24,126.56. If you were to do it monthly, the only thing that's going to change here, you're still going to use this top equation, and n would become 12, and then n here is also 12. And there you get approximately $24,202.53. So you make it a little bit more if you do it monthly. If you do it continuously, then you're going to use PERT. So you have 15,000 e to the 0.08 times 6. Here you don't have to worry about quarterly, 4, monthly, 12, etc. Here you make out the best. Make approximately $24,241.12. Okay, moving on to 9.2, we're going to look at composite and inverse functions. This is what you might remember as FOG from algebra, and you do things backwards. This little degree sign means following. So you're going to do the function of f following the function of g of x. It can also be written as f of g of x. So I'm going to skip right to an example here. If you have f of x equals 2x plus 4 and g of x equals 3x minus 1, and it's f following g of x, then wherever you see x in f of x, you're going to plug in g of x. So 2 times 3x minus 1 plus 4. Distribute, you get 6x minus 2 plus 4, which equals 6x plus 2. And then they want you to evaluate that when x equals 1 and x equals -3. So then you just just going to simply plug in 1 for x, and you get 6 plus 2, or 8, and negative 3 for x, and you get negative 18 plus 2, or negative 16. Okay. They'll also have you look at f following g of x versus g following f of x. They're not the same, okay? So just be cognizant of your order, and this was 2 examples in the book. If f of x equals 2x minus 3, and g of x equals x squared plus 1. And then we're going to look at inverses. So if f of x equals 2x plus 3, what you're going to do is you're going to change f of x to y, so y equals 2x plus 3. And then you're going to transpose the y and the x. So x equals 2y plus 3. Now you're going to solve for y. So subtract 3 and then divide by 2. X minus 3 over 2 equals y, which equals the inverse of x. So this is the function of x, and this is its inverse. Make this equal to y, swap y and x, and then solve for y. All right? And that's, the book is a little bit more in depth, but that's really all you need to know. Now, my first video was 37 minutes, and this, granted, I had written all this out in the first video, and this became 10 minutes and 6.5 minutes. So we'll see how this works. Be ready just in case we might need to do a Zoom on Tuesday, but hopefully you can bear with possibly the transposition of this looking like that as opposed to that. And my voice, etc., the downloading, what have you. And I'll get through this together. All right. Have a great weekend. Thanks for understanding. Bye-bye.